Hello there geographers, we are back with another video. Topic for today's video is going to be the Tectonics module, and one of the core concepts within that module is vulnerabilities. Let's go. So one of the essential things that you've got to do if you ever get a question on vulnerability with Tectonics is you've got to know your core vulnerability theories. If you don't know your core vulnerability theories, you're going to be missing out on marks. You may even just hover in that level 2. We're thinking there about sort of 5 to 8 out of 12, and what you really want to be doing is pushing yourself into that level 3 bracket where we're getting the 9s to 12 out of 12, and your vulnerability theories are the ways that you're going to be able to do that. So let's first look at this concept of vulnerability. What does it actually mean? Essentially, vulnerability is you are at risk. You are at risk of some kind of impact from any kind of tectonic hazard. And when we're concerned with people, it may well be the case that it's social and economic impacts. So some classic social and economic impacts might be, for social we might have death and disease. Economic, we might have reduced income. Now the hazards, obviously they come into play as well. Yeah, so we've got earthquakes, volcanoes and tsunamis. So when we're talking about vulnerability, we're asking ourselves the question, what is it that makes a community vulnerable to tectonic hazards? And there are a range of factors that you could discuss here that might mean that one community is more at risk from tectonic hazards than another community. And that's what we're going to go through now, but we're using those theories, those vulnerability theories, to draw out that information and connect case studies too. So what they give you is that ability to structure your paragraph in such a way that you are hitting the mark scheme criteria with everything that you're saying. So the first of our vulnerability theories is the simplest, and it is the DEGGS model. In that overlap where we get what we term a tectonic disaster, rather than it just being a tectonic hazard, we've got a tectonic disaster. And that's because a vulnerable population has been exposed to a hazard, and the overlap there is where we get the disaster. So if you're presented with a vulnerability 12 marker, then the DEGGS model is probably the simplest one that you can draw on. What we've then got to think about is, where is this theoretical model applicable to? What case studies can we use to actually back up the fact that this theory could be correct? Now remember, this is often termed your AO1 in the mark scheme, so the examiners will credit you for using real place examples. In fact, it's expected of you. If you don't do this, then you're only doing half a job, and again, you're probably going to lie in that level 2 bracket. So my favourite case study to use here is Pinatubo 1991. Now it's an old case study, but it's a good one nonetheless. The hazard was a VEI6 volcano. Now that is an explosive volcano, a very explosive volcano. And usually what that means is that the primary hazards are more severe, so the population might be more at risk as a consequence of that. So just an example of the physical characteristics of the hazard that this community might have experienced. Obviously with an explosive volcano, ash or tephra is going to spread very far from the vents. What we're trying to focus on here is what makes the population vulnerable. Now there's a number of things that we can always talk about with a volcanic hazard. With this particular community, what was it that made them vulnerable? Now it's a volcano, so what that means is that the population do have a number of warning signs before the volcano goes off. So it doesn't necessarily represent huge amounts of social vulnerability, but there may be significant amounts of economic vulnerability, and that's what we're going to draw on now. So what we're thinking about here is, it's the Philippines in 1991. They probably would have been classified as a developing country. And with developing countries, as well we know, there's going to be that over-reliance on the primary sector. And with there being that over-reliance on the primary sector, we know, don't we, it's probably likely to be agriculture in this case. So with an over-reliance on agriculture, that is what we would probably term an insecure form of income. It's very vulnerable to the effects or the primary hazards associated with volcanic eruption. Yeah, so it's going to be vulnerable to that ash cloud. As a consequence of this, and because there's fertile soils at the foot of the volcano, that probably means that they're going to be vulnerable to significant economic losses, not only in terms of lost crop yield, but in addition to that, many thousands of people, hundreds of thousands of people are going to lose their jobs, hundreds of thousands of people are going to lose their incomes. So in terms of actual impacts, that was evidence of the fact that they were vulnerable. We've got these particular consequences. So there we go. So it's at 70 million in losses and 650,000 people lost their jobs. So that's just our first example to demonstrate the utility of the DEGGS model in explaining vulnerability and that link to some communities being more vulnerable than others. What we're playing on here is the over-reliance on the primary sector. On to the next model. Okay, so the next model that we're going to look at is the hazard risk formula. Now there's quite a bit of overlap between these two theories. Whereas the last theory focuses very much on its vulnerability and it's the hazard, and it's very simple. This contains a few more components. So as you can see, it contains the same components as before. So we've got the hazard, and then we've also got this component of vulnerability, and the vulnerabilities would be the same between this formula and the last one. But we've got some new stuff to look at in this formula. Exposure. So exposure is an interesting one. So exposure can be thought of as a type of vulnerability. So depending on where a community is located, they might be more vulnerable. And this might be associated with proximity, like how exposed are they to the primary and secondary hazards, just because of how close they are to those particular effects. So if they're very close to the volcano, or they're very close to the epicenter of an earthquake. In addition to this, we've also got this component of manageability, and that's more a measure of resilience. So the degree to which a community is resilient is something that will have a direct effect on their vulnerability. The more resilient they are, the less vulnerable they are as a community. So a couple of case studies that we can link to this particular theory. So Haiti 2010, always a classic, a very popular one in the Tectonics module. I would always teach it every single time. It contains a number of different things that are very useful to us in the exam. But the way I like to link the Haiti case study to this particular formula here is by talking about the component of exposure. And it's with a very simple line indeed. And that's this. It's that 25% of the population lived within 20 kilometers of the epicenter. So that's quite high exposure to the high magnitude effects of the ground shaking. And if you remember, Haiti was a 7 magnitude earthquake, so that's a fairly high magnitude. Another case study where exposure is also a very useful component would be Indian Ocean 2004. Now everyone mentions Thailand in the Indian Ocean 2004, and it's quite right too. I think the main reason it gets a lot of press is because 50% of the people who died were tourists, so it got a lot of mainstream media coverage, particularly as there was a lot of Western tourists. But actually the most deaths were experienced by the community of Aceh in Indonesia. And that's because they were in closest proximity to the epicenter of the earthquake that actually caused the tsunami. So for this community here in Aceh, the tsunami arrived 20 minutes after the earthquake, which led to 168,000 people dying within that community, representing well over 50% of the deaths. So for me, using this formula of vulnerability, exposure becomes one of the most useful things that we can make reference to, in addition to obviously the factors of vulnerability that would amplify the degree to which exposure can increase vulnerability too. Okay, next up we're going to go for the disaster risk age index. So the disaster risk age index, it's nice and simple. It's just focusing on that component of age. So we're making specific reference to the elderly and the very young, and how if a population has large volumes of their population or high percentages where they are very old and very young, they are likely to be more vulnerable communities than others, and here's why. So if we just take the elderly, we have this factor here. So they're less mobile and they have lower reactions. So that process of evacuation is probably going to be less effective. They can't move as quickly, maybe they don't get out of the building in time, because the maximum that anyone's ever managed to achieve in terms of a warning from something like an earthquake is 60 seconds, and that's in Japan. The other thing to consider as well is that they are frail and they have weaker immune systems. That means they're more likely to die from secondary effects, so they might succumb to their injuries, they might succumb to any diseases that might be prevalent within the wake of the disaster. And then finally, in some communities they do have less access to technology or are less able to use it, so that's probably going to determine whether they hear those warning signs or not, which of course is going to determine whether they actually survive and get themselves out of a building because they've seen those warning signs. So the perfect example for this is the Tohoku 2011 tsunami. Again, a very popular case study, but it's very useful to use with age, and here is the statistic that demonstrates that. So 56% of the deaths from this disaster were those in the 65 plus age category, even though they were only 23% of the population. Now that represents disproportionate amounts of people who were killed in that age bracket there, which I've just rubbed off with my back. Now the next model, this is the king, queen, court jester of all theoretical models. This is probably the most useful model that you can use when you're discussing vulnerability to tectonic hazards. I would suggest that if you are not using this theoretical model in your answers in some way, shape or form, you are leaving marks on the table, and we don't want that. Got it. The PAR model is like a more advanced version of the DEGGS model. It shows us the progression of vulnerability. So it doesn't just state what that vulnerability is. It shows us what the root cause is and then how it develops into an unsafe condition that represented the vulnerability that that community experienced at the time of the tectonic hazard. I'll show you now. So as I said before, it shows us that progression of vulnerability. So we start off with the root cause, and then that goes to a dynamic pressure, which results in an unsafe condition, which is the specific vulnerability that that community experienced. So the beauty of this model is that it helps you structure your paragraph. It helps show the examiner that you can engage in that practice of developed connections and relationships. What the examiners want to see in your paragraph is not scatterbrained thinking, oh this, oh and this, oh and this, oh and this, oh and this. They want to see that you can say this leads to this, leads to this, leads to this, death or something. So that's what this model can do for you. It can help you structure your paragraphs to make sure that you are demonstrating that competency to the examiners. Now, there are two case studies that I would recommend that you use with the PAR model. These two are Haiti 2010 and Turkey 2023. So let's go through what our most common root causes are, and I'll demonstrate that with Haiti first. First of our root causes is going to be low levels of economic development, and we've already explored that, haven't we, with the Philippines and the Pinatubo eruption. Now, what we said there was because of low economic development, they relied too heavily on the primary sector, and that meant that they were economically vulnerable. Now with this, low economic development can lead to a number of dynamic pressures. So we're just going to go down the route of one dynamic pressure so we can stay on one train of thought. Now what it's a good idea to do is always try and put in a little bit of place-specific AO1 next to each of the points across the PAR model. So with Haiti 2010, the GDP per capita was $660. Which is very low. So that suggests to us that levels of economic development are not very high, because if GDP per capita is this much, chances are that overall GDP is also going to be low as well. So it signals to us that the country doesn't really have a lot of money. The dynamic pressure that then leads to is poverty. A lot of the population live in poverty. Output is low, which means they are predominantly working in sectors that don't produce goods of high value. That probably means that they're not paid very well. So poverty. And the specific bit of AO1 that we can use here is that 72% of the population lived on less than $2 a day. So what, pray tell, does that then lead to in terms of an unsafe condition? It leads to this. It will lead to large volumes or large amounts of non-aseismic buildings, because the population can't afford to build non-aseismic buildings. So a very common statistic that's put forward is that 90% of the buildings in Haiti where the earthquake took place, so the capital in Port-au-Prince, 90% of these buildings were made with a weak, non-reinforced concrete. Not helped by the fact that 80% of the property there was informal housing because of large volumes of rural to urban migration. So the capital is essentially, the capital has a high population density, but a high population density that live in unsuitable housing. 200,000 homes collapsed, and there were 230,000 deaths. So that shows you that progression of vulnerability from low economic development to this death toll here. And what you can see is that this would be a very well structured paragraph. So you must learn how to use the PAR model in your answers, particularly when you've got a question about vulnerability. Now the next core factor that we can think of, or the next root cause that we can think of, is weak governance. Now weak governance can be a more important factor than low levels of economic development, particularly in, well, when you've got emerging economies. We can say that the country does have quite a high GDP, but the governance systems around hazard management were particularly weak. The best one to use here is going to be Turkey 2023. So a number of things were happening in Turkey around that time, and the government, the Erdogan government, didn't necessarily act in the best way prior to the hazard and then following the hazard, and that's a consequence of poor governance, weak governance, particularly around hazard management. So one of the dynamic pressures that comes from weak governance, and it's very common where there's high deaths within a particular earthquake, is that there's been a lack of the enforcement of building codes or building regulations. So the specific bit of AO1 that we can put here is that in 2018, 100,000 properties were granted a building codes amnesty. So what that meant was that they didn't enforce the building codes or the building regulations on properties that had essentially already been built. So there was no repercussions for the fact that they'd done that. What they did was they prioritized building as quickly as possible. Now, the unsafe condition was that there was a high volume, once again, of non-aseismic structures. As such, 6,000 buildings collapsed like pancakes when the 7.7 magnitude struck in 2023. Very sad indeed. And as a consequence of all these buildings collapsing, that contributed to a death toll that was 50,000 plus. Now, it's not only this. Governance isn't just in the lead up, okay? It's not necessarily just in that mitigation phase of the hazard management cycle. So one of the unsafe conditions was, and we're just going to skip forward, is that there was a poor response. Usually when we're talking about that, there's a delayed search and rescue, and it was delayed by around 2 to 3 days. Now, the reason for that is that the government, again, a symptom of weak governance, they removed power from the army. So they took that power away from the army. Normally, if you're going to choose an organisation within your country to respond to a tectonic hazard, you would say, let's send the army. They're the most well equipped, they're used to working together, they've got all the big machinery, they can usually get to people within that critical window of 24 to 48 hours to ensure as many people survive as possible. Instead, the Turkish Disaster Authority were given the power to organise the response. So the army eventually were called in, but they had to wait. There was a delay with the Turkish Disaster Authority giving permission for them to go in. Why you would need to wait for permission, I don't know, but obviously they're the army, they're deployed when they're told to. Other things as well that we can bring in is that the government decided to block Twitter, well, called X now. Twitter was being used to geolocate people. They were communicating with people to say where they were within the rubble, but they closed down Twitter as a way of reducing the amounts of negative press that the government would receive for that poor response effort. I feel like that's kind of like a self-serving cycle, but never mind. So weak governance can sometimes be more important, but again, you can use the PAR model to explain how you can get to that point of high vulnerability and therefore disasters where there are high death toll. And finally, we have the Swiss cheese model. Swiss cheese model, again, it's a fantastic model for taking that step back and saying, look, vulnerability is normally context specific. So normally there are a specific set of physical development and governance conditions or government conditions have led to a very specific set of outcomes. And I'll demonstrate that in a second with the use of some case studies. But in terms of a visual, it's a bit like this. So as you can see, these all represent like your physical, your development, your governance, maybe there's some random factors here, and all of these things, these specific conditions all line up to produce a very specific outcome. So there's a case study that I always teach every year to my students, which typifies this kind of, or is very useful to use with this theoretical model of vulnerability. And that is BAM Iran 2003. So I'm going to show you that there were specific physical, governance and development factors that led to the outcome that they experienced. The physical one, and these are dead simple. First one, it was winter. The second one, it happened at 5:23 a.m. So both of those physical factors, winter, that means that when the buildings collapse and people are exposed to the elements, there's an increased likelihood of hypothermia. Happened at 5:23 in the morning. That meant that most people were caught off guard because probably most people were asleep. And finally, there was a 7-kilometer focal depth. So with the 7-kilometer focal depth, obviously that meant that there was less distance over which the energy could dissipate, and therefore there was the intense ground shaking as a consequence. So our development factors, now because there was lower levels of economic development here, it meant that there were less trained medical professionals. Now because there's less trained medical professionals, that means that people are more vulnerable and are more likely to succumb to their injuries in the wake of the disaster. And then finally, specific governance factors, and this again is a very common one. It's the lack of enforcement of building regulations. But to be fair to this city, it was an ancient city, many of the buildings being 2,400 years old. So I don't think there was that much by way of building regulations in the past or a seismic technology. So the fact that it was an ancient city also compounded the degree to which they were vulnerable. And as a consequence of this, 26,000 people died. But if you take out just one of these conditions, maybe you take out the fact that it's 5:23 and maybe it happens in the middle of the day, maybe midday, maybe that number would be lower. So it's just there to kind of explain vulnerability is not necessarily down to just one thing. It's a combination of different factors acting together. Okay, so those that are avid watchers of this YouTube channel should be aware that we always do some some content, and then we always relate it to an exam style question just so you can see how you apply the knowledge that you've just gained. Okay, so this is an assess question from the paper 1 of the 2018 series, I think, and it's an assess question. Now, assess questions in Edexcel A Level Geography, they will always be 12 marks. Now, half the battle in the assess question is making sure that you're writing in the correct way, make sure that you get level 2 or above. So you've got to ensure that you're getting balance. Balance. You cannot leave that question without balancing your response. But we've also got to know how exactly is it that we are assessing here, because depending on the wording of the question, it gives you clues as to how you have to write and how you have to get that balance into your response. So I always say, read it once, read the question again, and look at the next 2 words after the command word. So we are assessing the reasons why some communities are more vulnerable to tectonic hazard than others. So that says to me that we start with a reason. We have to construct our paragraphs in a certain way. So what we've just been through is a really good way of making sure that your paragraph contains some solid A-level style theory, some AO1, and then linking it back to an outcome, which is evidence for the fact that a specific community were vulnerable. Let's have a look at an example of how we might do that in our first opening paragraph. So what I want to do normally in my opening paragraph is impress the examiner from the off. I want to show them, boom, there you go. This is what I'm about. So I'm going to start off with the PAR model and explain about the PAR model and say how it shows the progression of vulnerability. It starts with the root cause, which might be low levels of economic development, which might then lead to poverty, which might lead to a lack of aseismic building, and I would probably use heating. Similarly, I could go down the route of weak governance and I could use Turkey. So as long as we're using that method of this leads to this, leads to this, leads to this, we're presenting the reason. And that reason so far is low levels of economic development. But we don't just stop there. This again is the importance of reading the question and the importance of writing in such a way that you are going to get higher marks. Look at the wording of the question. Some communities are more vulnerable to tectonic hazards than others. This here says we've got to make a comparison. Yeah, we've got to make a comparison. So not only would I use heating, when I get to the end of that paragraph, I will emphasize that they are more vulnerable than a community such as Japan. High levels of economic development, able to ensure that most of their buildings are aseismic. And the evidence we could use for this is that in the 2011 disaster, there were only 1,000 deaths, or only 10% of the deaths, so there were 16,000 altogether. So only around 10% of those deaths, so we'll call it 1,600 actually, were from the earthquake event. Even though it was a 9 magnitude, it was actually higher than heating. So we're saying there that this currently represents a very important reason why communities are vulnerable. We can't just then say another reason why communities are vulnerable, another reason why communities are vulnerable. That's not assessing, yeah? That's not writing in a judgmental way. That's not making comparisons or counter-arguing or showing that you've got that skill of considering the argument from another perspective. So we've got 2 options on the assess side. 1, we've got the decreasing the degree. 2, we've got something that might be more important. So the most relevant style to this particular essay is this one here, where we're thinking about a factor that might be more important. Now we can do a little bit of a double header in our first thing, so I'm just going to basically show you how to balance and how to consider this from another perspective. That's all we're doing in the assess side, just considering it from another perspective. Not trying to eviscerate this argument here. All we're trying to do is, yeah, but when we consider it from this perspective, actually we might think that in Japan, you know, that specific place there, when we look at a specific community or a specific group of people within that community there, the most important reason for vulnerability there is something else, okay? So in Japan, the more important reason, so levels of economic development sometimes aren't the most important reason. There's other more important reasons. Can you hear the language I'm using? This is the language I want you to use. The factor we need to consider in Japan is actually age, demographic characteristics. So the Tohoku 2011 disaster shows us that sometimes demographic characteristics are the most important reason why some communities are more vulnerable than others. So the specific community that were impacted by Tohoku 2011 and the tsunami and the earthquake, remember 56% of the deaths were in the 65 plus age bracket. And once again, we can bring in that fundamental core theory, which is the disaster risk age index. So in both our opening paragraphs, what we've shown is that we know how to use theoretical models. We've got 2 case studies, so our AO1 is going to be high. We've structured the paragraphs to show that this leads to this, leads to this, leads to this, connecting vulnerability to outcome. But we've also shown that we can balance and consider the argument from another perspective, from another place, different groups of people, different spatial scale, scales. That's all we're trying to do, and that's something that I always refer to in my wheel of AO2. And then we're hitting that assess. Say you ran out of time and you only had this and this. 2 really good paragraphs. Maybe we've got a page of writing there. You're getting at least 6 marks out of 12 because you've demonstrated those core competencies. The rest of the marks will come from the rest of the paragraphs. Now, this is an essay that I went through in the first session of my Summer Accelerator Programme. So those of you who are interested in the Summer Accelerator Programme, it's basically a program designed for year 12s moving to year 13, looking to make the best start possible to year 13. I promise you that year will go like that. And so what you want to do is try to get yourself ahead before you get into year 13. More than anything, prevent the summer slide that takes place over the summer period when geography is not a priority. What I'm trying to do with this Summer Accelerator Programme is just keep it ticking over. You can hit the ground running in year 13 and succeed in that A-level geography. Okay, so that brings the video to a close. Hope you enjoyed it. More videos to come over the summer holiday. Enjoy the weather.